I kind of like lakes. I always loved lakes, and as a kid growing up I've been around lakes, and that just happened to be an area that I was interested in. It's also a bit more specialised too. Whilst many other people are actually working on using scuba, working underwater. The total thrust of my work is really trying to understand plant communities, what we have, what they mean, and how they change, how they reflect the conditions of the environment they're in. And for me, the particularly interesting thing is that any plant growing in a lake has a story to tell. I got to the point there where I could jump in a lake, and after just 1 or 2 dives I could tell you a lot about the lake, but the hard thing was to sort of try to translate into some kind of a meaningful score and be able to compare it with other lakes. Our lakes range from being in excellent condition right down to absolutely abysmal condition, and unfortunately a lot of lakes are continuing to get worse, and that really comes through increasing pressure from agricultural development, land development, drainage of wetlands, and also invasive species is a big factor. So yeah, we do have a situation where more of our lakes are deteriorating both in water quality and invasive species, and that's not just from plant invasive species, it's also from pest fish as well. Plants are actually really important for lake health, and they do a lot to actually maintain good quality. The trick here is to sort of try and get the right balance of plants. The invasive plant species, although they can still be beneficial, they certainly aren't as good as actually having the native plants. So about 10 years ago, I attempted to try to come up with a method that we could better characterise a heat water body and say this is the condition of the water body. One simple example, if you have plants growing down into deep water, then that reflects good water clarity, because plants are limited by water clarity. And the good thing about plants is that they're kind of like are rooted. They can't go anywhere, they can't run away. They're not like fish. Fish can just swim away, and it's very hard to get a good idea of what fish are in a lake. The thing about plants, they basically integrate those conditions. They stay in the same place while they're there. They actually mean something. And so that's when I developed this Lake SPI, SPI, stands for Submerged Plant Indicators. And in the process of developing, we came up with a native condition index and an exotic or invasive condition index, and then we combine those to come up with the Lake SPI score. Now the interesting thing here is that we can actually compare any lake to another lake, and we can do that because we identify what the pristine and original condition of the lake would have been, and we can score the current condition relative to that original score. And by doing that, we can then sort of say this lake is as close as it can possibly be to its maximum score, or it may be way down the scale. So the method has actually allowed us to come up with an objective method of comparing lakes on health and actually monitor the change in condition over time.